This is the video lesson for wave speed equation. The learning target for this lesson is I am learning to identify the relationship between a wave's velocity, wavelength, and frequency, and to calculate a wave's velocity based on its wavelength and frequency. The success criteria for this lesson are I can identify the formula for wave speed. I can identify the relationship between a wave's velocity and its wavelength and frequency. And I can calculate using the relationship between a wave's velocity and its wavelength and frequency. So let's talk for a minute about a wavelength and frequency. Here you can see a wave with 1, 2, 3, 4 wavelengths. So it's a medium wavelength. It has a medium number of wavelengths in this window, which means it has a medium period, let's say. So a certain number of wavelengths per amount of time, that's the period. And so in comparison to this wave, which has only 1.5 wavelengths in this amount of time, which would be its period. So the second wave has a much lower frequency than the first wave. So this wave with 4 wavelengths has a higher frequency than this wave with only 1.5 wavelengths. So what is the formula for wave speed? So the formula is V equals F times lambda. So V stands for wave speed or velocity, F stands for frequency, and lambda, the little upside down Y looking shape, stands for wavelength. So you multiply frequency times wavelength, and that gives you the wave speed. So what about the units for wave speed? So again, the formula for wave speed is V equals F times lambda, or frequency times lambda. So the units for frequency are hertz, or per second, and the units for wavelength are meters. So we have hertz, or per second, times meters, and that gives you meters per second. So the units for wave speed are meters per second. So what about the relationship between wave speed, wavelength, and frequency? So we can solve the equation for different variables to give us some different information. So if we want to find the frequency, we use the equation rearranged a little bit so that frequency is equal to the wave speed divided by the wavelength. So when you look at this equation, you realize that if you make the wavelength longer, the frequency has to get smaller. And if we want to find the wavelength, wavelength is equal to the wave speed divided by the frequency. So if we look at this equation, we recognize that when you make the frequency larger, the wavelength has to get smaller. All right, so now we're going to work some examples using wave speed equation. So in this example, a wave has a frequency of 10 hertz and a wavelength of 30 meters. We want to know what is the wave speed. So our equation for wave speed is V is equal to the frequency times the wavelength. So our frequency is 10 hertz. So it's 10 per second. And our wavelength is 30 meters. So that is going to be 300 meters per second. Okay, for example 2, the speed of a wave is 65 meters per second. If the wavelength of the wave is 0.8 meters, we want to know what is the frequency of the wave. So our equation for frequency of the wave is the velocity of the wave, or the wave speed, divided by wavelength. So we have wave speed is 65 meters per second divided by the wavelength, which is 0.8 meters. So that is 81.3 hertz. Okay, example number 3. A wave with a frequency of 500 hertz is traveling at a speed of 200 meters per second. We want to know what is the wavelength. All right, our equation for wavelength is the wave speed, V over the frequency. So we have wave speed of 200 meters per second divided by the frequency of 500 hertz. So remember that hertz is equivalent to per second. So our per seconds would cancel here, and we'd end up with meters. So we have 200 divided by 500. That's equal to 0.4 meters. So the wavelength of this wave is 0.4 meters. All right, everybody, keep asking questions. It's how you learn new things.